This is Karthik. Today I'm going to discuss an important flow control mechanism used data link layer called sliding window protocol. In data communication, the sender and receiver may operate at a different speeds. If senders send data too fast, the receiver may not be able to handle it, which can lead to a data loss. So, to avoid the problem, flow control mechanisms are used. Sliding window protocol is an efficient flow control technique that allows multiple frames to be transmitted before receiving an instructions. So, with that, we'll move into that video. We move that into the video. So, today's agenda we'll be discussing the introduction to the flow control topic, and why do we need the sliding window protocol, okay, and the basic concept and working of sliding window protocol. And there are two types of sliding window protocol. One is go back and another is selective repeat. And we'll discuss in detail go back and selective repeat, and we'll compare both of them and come to a conclusion which is more efficient and why do we use that in later part of the video. So let's get into it. So first of all, what is flow control? So flow control is a mechanism used in data communication to manage the rate of data transmission between sender and the receiver. Like flow control is like uh, if it acts as channel where the sender and receiver operate at compatible speed. So like the problem arises like if a sender transmits the data faster than the receiver can process it, so it leads to data loss. So we know that. So if so the flow control will ensure the sender and receiver operate at a compatible speed. And we'll proceed like there is another protocol which is stop and wait protocol. So the problem in the stop and wait protocol is like if we send a data here, one second. So if we send a data we send a data frame one, and the receiver receives the data and gives an acknowledgement. So here in this stop and wait protocol, the sender sends the data and the receiver gives an acknowledgement that I have received the data. So the problem here is it, there's only one frame can be transmitted at a time, and if it takes only one frame at a time, means it generally takes so much time to uh, send data. So the channel idle time will be more, and it is poor in efficiency. So in the frame one is sent. So the frame one is sent, and at receiver end, they'll give an acknowledgement. So it will send frame by frame data. So it waits for the uh, receiver to give an acknowledgement to send the second data. So it takes so much time. So the concept of sliding window protocol came. So why do we need sliding window protocol? To improve the channel utilization. The sliding window protocol can send multiple frames without waiting for the acknowledgement from the receiving end. So it's like it can send a set of frames without waiting for the acknowledgement from the receiver end, and it has better bandwidth utilization, and it obviously reduce the ideal time of communication channel, and it is more efficient in a high delay networks. If in a high delay networks, it is very efficient as uh, it sends multiple frames of data at single go. So the basic concept of sliding window protocol is both sender and receiver maintain a window. So like a window is like the set of frame sequence numbers. So represents frames that can be sent and receive at a time. So at sender window, frames are allowed to send before receiving an acknowledgement. At receiver window, frames are expected to receive. So like in a sender frame, like frames will be there'll be a set of size for the protocol. So the set of protocols will be sent. So that will be at sender window, and at the receiver window, it will wait for the sender window to send the set of data, and it will acknowledge and it will be send it back. So it's so like to example, this is an example how that sliding window works. Like at initially the sender window has eight frames. So 0, 1, 2, 3, 4, 5, 6, 7. Okay, and the size is 4. So uh, at initially the sender window will send 0, 1, 2, 3 frames, and 4, 5, 6, 7 it will be at hold. So after receiving an acknowledgement for the frame 0, it will be moved forward. So 1, 2, 3, 4 will be sent. So like after receiving an acknowledgement from frame 1, so it will be like 2, 2, 3, 4, 5. So 2, 3, 4, 5. So this is how the sliding window protocol works. Like each after each acknowledgement, the data will be moved. So this is how the sliding window protocol works. So before going too deep into the sliding window protocols and the two types of sliding window protocol, we will discuss key terminologies like sequence number, a unique identifier assigned to each frame, and window size. So this is the window size. So this is the window size. So the maximum number of frames in a window which can be sent, and the ACK, which is acknowledgement. So confirmation message which is sent by the sender. And sliding mechanism, a window moves forward as acknowledgement is received, like sorry, this one. So as the each acknowledgement is received, the frames are moved forward. So this is the sliding mechanism. So these are the two types of sliding window protocol. One is go back in ARQ protocol, and another one is selective repeat ARQ protocol. So these are the two main types of sliding window protocol. So we'll go deep into the topic. So first we'll discuss go back end protocol. The core principle of this go back end protocol is the receiver accepts only frames only in a correct order. So if frames are sent in an order like 0, 1, 2, 3, 4, at the receiver end it receives in the same order. Like it receives only at 0, 1, 2, 3, 4. So the sender can transmit multiple frames, and if a frame is lost or damaged, the subsequent frames are being discarded, and from the frame which is lost, again it is retransmitted. So sender retransmits from the last frame onwards. So we'll take an example for this go back and protocol. So here in the transmission, the sender sends the data in an order like 0, 1, 2, 3, 4. The sender sends the data in at 0, 1, 2, 3. It's an example. So at first the frame 1 is acknowledged, so it is okay, and the frame 0 is acknowledged, and it is okay. At the frame 2 is also acknowledged, and it is okay. And when we come to the frame 2, so the frame 2 is lost, the data is being lost. So from after that frame 2 onwards, so from frame 3 onwards, the frames are being discarded, and again it retransmits from, it will go back to the n is equal to 2 from where the data is being lost, and again it transmits from second frame onwards. So even though if the frame 3 is okay, even though frame 3 was acknowledged, it will be retransmitted again. So from second frame onwards, the frame will be retransmitted. So here, if the second frame is lost, from second frame onwards, 2, 3, and so on, it will be transmitted. The characteristics of go back in. So the advantages of go back in are like it is easy and simple to implement, and it needs only a small buffer. It needs only a small buffer for this go back and protocol, and it is easy to understand as well. But the disadvantages here are it retransmits correctly received frames also. Like here, if you take an example, like here, if the third frame is okay, the third frame was okay, but it's before frame, the second frame was lost. So from second frame onwards, it retransmits, right? So again, the third frame is retransmitted. So even though the frames are being correctly received, it again retransmits again it retransmits the correctly received frames as well, and it wastes bandwidth, and it is inefficient for high error rates. So we'll move to the second type of protocol, which is selective repeat protocol. The core principle of the selective repeat protocol is receiver can accept frames out of order as well. Here in go back in protocol, receiver accept only frames in correct order, but here it can accept frames out of order as well. So if you're sending in sending an order of frames like 0, 1, 2, 3, 4, it can accept the frame order as well as like 3, 2, sorry, not 3, 2, 1, 2, 4, 3. It like as that as it can receive, like it can accept, receiver can accept these type of frames as well. So out order frames are stored, like if the out order, if second frame is lost, so the out order frames are stored in a buffer, and only the last frame are retransmitted. So which is more efficient, but it is more complex to implement as well. So we'll take an example. So this is an example for selective repeat protocol. So in this transmission, the sender sends the data like 0, 1, 2, 3, 4, and at 0th frame is acknowledged, and it is okay. And the first frame is acknowledged, and it is okay. And here the second frame is not acknowledged, so the data here is lost. So the third frame here will be stored in a buffer, and the second frame alone. So only the second frame will be retransmitted. But in case of go back end protocol, the second frame also will be retransmitted, and the third frame also will be retransmitted. That's the difference between like go back and selective repeat protocol. So here the data will be like discarded. The second frame onwards, the here the subsequent data will be discarded. So from second frame onwards, it will be discarded. The frames will be discarded, and from second frame onwards, the frames will be again retransmitted. But in selective repeat protocol, the only this frame which is lost will be retransmitted, and the third frame will be stored in a buffer, so it is no need to be retransmitted. So the characteristics of a selective repeat, the advantages is has better bandwidth utilization compared to go back in protocol. It only transmits the frames which are lost. So there is here that here the disadvantage, the go back and disadvantages is it retransmits the correctly received frames also, but here it only retransmits the later sorry, the frames which is lost, and it is more efficient compared to go back end. So the disadvantages here is it is more complex to implement, and it need a larger buffer. See here, like, because here we have taken we have contained ourselves to only frame 3. So if it is frame 4 or frame 5, we need a larger buffer to store more frames. So we need a larger receiver buffer is needed, and it is more processing overhead. So this is the comparison between go back and prototype and selective repeat prototype. So at retransmission, uh, it sends multiple frames again. So it sends multiple frames. Like if the second frame is lost, from second frame onwards, it retransmitted second, third, fourth. It retransmitted. But in selective repeat protocol, only the last frame is sent back. So like we'll go to the example. So see, so here the retransmitter, the sender retransmits from second frame onwards. But in selective repeat, in selective repeat protocol, it only transmits the last frame. So it's only transmits the second frame. So out of order frames. Here the out of order frames in go back N are discarded. So here the after if the second frame is lost, from third frame onwards, the out of order frames are being discarded. But in selective repeat, these are not discarded. These are stored in a buffer. So that's out of order frames are in go back N it is discarded. Here it is stored in a buffer. The efficiency of go back N is very low, and the efficiency for a selective repeat is high. And at receiver buffer, for go back and only like small receiver buffer is needed, like, because it stores only one frame which is being which waits for the acknowledgement. So only that one frame size buffer is needed. But if we take an example for this selective repeat, we need a larger buffer size. As I said earlier in this example, we have contained ourselves only to third frame. So we have taken only third frame stored. But if we take example as 4, 5, 6, 7, 8, so we need W frames, W, like it's like n number of frame size we need. And complexity, it is simple. It's simple, but here it is more complex to implement or something. So bandwidth usage, here the go back and bandwidth usage is very less, wasteful, but compared to selective repeat is use the bandwidth efficiency. It use bandwidth efficient more efficiently compared to go back in. So at last we have come to the summary. So like sliding window protocol improves the channel utilization by allowing multiple frames to transmit. So uh, we have seen that first protocol, right? That stop and wait protocol. Here that only one frame at a time is transmitted, but in sliding window protocol, multiple frames are being transmitted, so that it improves the channel utilization. So window slides forward as acknowledgements are received. So window slides as the acknowledgement is received. The zeroth frame is receives acknowledgement. The window slides moves forward. So we have seen that example previously. So we'll once again go there. Here. So initially at the center window is 0, 1, 2, 3, 4. Once it receives the acknowledgement, it moves forward. That is second we have discussed. And go back N is a simpler but retransmits multiple frames. So as we discussed earlier, like go back N is simpler, but it retransmitted from the last frame onwards. Selective repeat is more efficient but more complex, as it only retransmits the last frame only. And the in reality, we can use both go back and selective repeat, but the choice depends on the network condition and its requirement. End of this video. So there must be a few questions going on in your mind. So like questions like, is sliding window protocol is only used in data link layer or in any other layer? So the answer is yeah. Sliding window protocol is not only used in data link layer, it also used in transport layer as well, especially in TCP for the flow and congestion control of. So we use sliding window protocol. And you guys might have another question, like why don't we always use selective repeat protocol, as it is more efficient compared to go back in? Since selective repeat protocol is more efficient compared to go back in, but since it needs more memory and it is more complex at the receiver end, in simple system go back in is preferred compared to selective repeat protocol. That's all. Thank you.